So, hi everyone, and welcome to this new episode of Additive Talks. If you are joining us for the first time, make yourself comfortable. Additive Talks are simply a series of panels that focuses on discussing the use of 3D printing or AM technologies in a given industry. If you've been here before, thank you for listening to our insight into the world of additive manufacturing. My name is Katie Finze, managing editor at 3D Adapt Media. And I would like to give the floor to our experts around this table so that they can introduce themselves as well as the company they are working for. So we'll start with Anna. Anna, good afternoon or good morning, because I
Yeah,
still
hello.
right.
Yeah, it's a good morning my time in Florida.
Okay. So please, Anna, tell us more about you and Happy Scroll, please.
Oh yeah, absolutely. So my name is Anna Chen Yun Tai. I'm a CEO and founder of Episcore. We are the company that been pioneering the construction 3D printing industry. And so we the developer of the proprietary robots that features the true mobility and portability. And so during our journey of trying to disrupt this industry and cracking the code of how to rethink construction, we delivered several really landmark projects, not only for us, but for the entire industry as well. For example, we 3D printed the largest building on Earth that was done for the Dubai government. And today, it's still the official Guinness World Record as the largest 3D printed building in the world. So we also the finalist of NASA competition that was about the robotics, additive construction technologies that someday can be used to construct the shelters and habitats on Moon and Mars for first to arrive. The main goal of the competition was to 3D print the elements of the future habitats in a fully autonomous way. Because we all know that on Moon and Mars, we are not going to have uh, a lot of human supervision, right? Everything should be very autonomous. And last year was also very busy for us. We 3D printed two buildings in the United States, one in Missouri, and another one, it's a commercial building in Boca Chica, Texas. And so this year, we're very busy to prepare for the scaling and growth next year. We have several projects lined up. And so keep working hard. And I hope that next year we can share more exciting projects in the United States.
Thank you, Anna. What about you, Stefan? Tell us more about you and what you do in the construction 3D printing industry, please.
Sure. Hi, everyone. Stefan Mansour. I come from about 17 plus years in the construction sector, working for a major general contractor based out of Europe, Athens, Greece, to be specific, for about 17 plus years. My focus and role in that company was introducing innovative technologies into construction. So we're looking at different approaches on how to actually better the operations in our projects, especially in offsite and remote areas. So that shifted primarily to 3D printing. We 3D printed a house for the Ministry of Housing in 2018 in Saudi Arabia, and that was sort of like creating sort of a subcontractor relationship with CBE at the time, who was helping us as a technology provider to provide that building. One of the biggest issues that we came across early on is the issue of certification and how we will certify that building as structure. As a general contractor, we have the responsibility of taking ownership, liability, and providing the guarantee and warranty for that. So looking at the drawings and looking at the structure, it was apparent that early on there was a sort of like a disconnect between the 3D printing and the general contracting construction sector. So that's sort of like stuck with me, and we had to refine the drawings in order to actually include traditional columns and beams for that. So having finished that project, we tendered for other projects in Dubai, not necessarily just in cement-based materials, but also with metals and polymers, looking at different avenues of how to incorporate 3D printing into the construction sector, not just in houses, but in other areas as well.
Okay.
I've since left the company and moved to Toronto, Canada in 2020. So sort of kicked off on my own initiative, trying to create a committee for standards, was able to successfully create one using global participation, in March of 2021. So it became an ISO Joint Group 80, ISO ASTM Joint Group 80 effort. We have actually gone through first round of commentary. We have prepared a document for a second round of commentary. So hopefully we'll be able to publish by end of next year, or sorry, end of this year, early next, to have an ISO ASTM standard put in place. And this will be a global standard available to everybody. In addition to that, doing consulting, so consulting on a private level, but also as a consultant to Wohlers Associates powered by ASTM, providing their efforts to actually incorporate and kick off the additive construction sector with Wohlers Associates.
Okay, thanks, Stephen. So that's, I mean, there's a lot that is going on in the construction industry right now.
Yes, absolutely.
And yeah, but but I sometimes feel like there is a race to be the first to build things, with construction 3D printing. Do you feel that race as well? I mean, do you feel that there's a kind of race between manufacturers of construction 3D printers and contractors? Do you feel it as well?
It's not so much a race, but it's as much as trying to meet the demand that is out there for the construction sector. There is a lot of issues that the 3D printing could address, mainly when you talk about labor shortage, when you talk about supply chain issues and lead times, and also the cost of material as well.
Okay.
There's a housing demand that is lagging, existing, and coming forward. So people and construction companies and other people as well are looking at different ways to actually address that, to meet the demand that's coming, but also to address the issues that the construction sector is facing. So it's not so much who's going to do things first, but trying to find a better way to do things and to meet the demand that is coming.
Okay, that's the point of view of a consultant. Anna, what do you think about it?
So I think it's just because the industry of the 3D printed homes are relatively new,
Okay.
and there are a lot of opportunities where you can be first, right? So
Yeah.
I think that's absolutely fine, right? You can be the first residential house. You can be the first residential house in Europe. You can be the first residential house in Australia. So there are a lot of spots and rooms when you're relatively faithfully can be really first. And it's really exciting because the industry is new, but it's forming so fast and it's growing so fast. So I wouldn't say it's a race.
Mm-hmm.
Maybe it's a very healthy race, but it because there is opportunity to take all of the the spots, right? Because the industry is new and it's forming very fast. So I think as long as people and companies validate their first term,
Yeah.
that's I think relatively fair.
Okay. Thanks. So, in today's conversation, we will discuss how the building industry evolves with regards to manufacturing processes, cost, and standardization. And just a quick reminder for the audience: please feel free to ask, any questions you may have in the Q&A chat in front of you. Write any remarks that you have regarding, the insights of our panelists here, and then we'll pause at some point along the conversation to read them and discuss, your thoughts or your questions. So that being said, let's start with manufacturing. There are a variety of 3D printing methods used in construction today, the main ones being extrusion. Apart from extrusion 3D printing, what other manufacturing processes can be a best fit for 3D printing houses? And I will start with Anna, this one.
So honestly, I just see that the extrusion with the concrete, it looks like the more viable solution uh, uh, for the application uh, in a pretty harsh construction conditions, right?
Okay.
Because it has to be done in uncontrolled environmental conditions. People with all of the level of skills should be able to use it if you really want to scale it up really quickly. So I think that the concrete extrusion is the most viable right now.
Mm-hmm.
But like talking about the different 3D printing technologies, I know that for construction on Mars, NASA is very interested in exploring a sintering. It of course have a lot of actually different advantages and disadvantages. But sintering is also the approach of
It's
the
also another great fit. I mean, interesting feat. Okay,
Yeah.
Stephen, do you agree with that?
Yeah, absolutely. And the thing is that you have to find a solution that works, that is mobile, that is versatile, that you can adapt and put into different applications. So, I mean, there were several solutions when 3D printing first kicked off, and or we emerged in the 90s. So, like in Enrico Dini with the D shape, and he had this big printer where you just layer a layer of sand, and then you put an adhesive, and then you do sort of like a powder bed fusion type setup. But that's a bit too big. It's not easily movable or detachable or mobile. So the when you're looking at the extrusion and the method that we're using today, it's the most versatile and most um, mobile type solution that they actually can be adapted in different construction sites. The construction sites are very limited in space, limited in environmental conditions. So it's the best thing that we can do now. That doesn't mean that this is the only way moving forward, and there are not other ways that we can develop things. So.
Okay. Okay, and I know, Happyscar is a manufacturer of construction 3D printers, but do you feel that there are any areas for improvement? Because I think that your technology is an extrusion-based technology, right? Process. So do you feel that there are any areas for improvement in order, to speed the process or, to make these type of process more accessible to, contractors worldwide?
So at this moment, we more focus on the, I think, software, how
Okay.
the companies can quickly create the G code, how they can incorporate it in the existing construction processes. So it's more like right now, regarding to integration of
Oh,
this technology into the construction process.
okay.
Again, it's like the creation, the documents, workflow optimization,
Mhm.
G code, and everything like that. So it's more towards the end product, like the 3D printed walls and how to build them. Yeah.
Okay. And right now I will ask a question that is specifically that is specifically being written for Stephen. Could you please explain the concept of digital inventory in the construction industry? Is it the same concept that we use, in supply chains supported by conventional additive manufacturing processes? That's something quite new in the building industry.
It is even digital inventory could play a big role in construction, and the reason why is as a general contractor, we were mobilizing big projects,
Okay.
all refineries, mechanical projects, and so on. So we had to have a big sort of like a footprint when it came to inventory and spare parts and parts that are coming that were needed for the project. This was first very cost heavy. It required a large footprint, and then for parts and pieces that might and might not be used. So there's a lot of overhead. And in typical construction, sometimes you would mobilize your inventory. You would have this big warehouse. You would have to man it. There would have to be some kind of tracking. But then, sort of like at the end of the project, you could not reconcile what you bought and what you used and what is left over. So things were always off. And there was always sort of like a write-off when it came to the inventory and the construction. Also, when you're dealing with lead times, especially for a part that is not available, for example, and you're waiting for the OEM to deliver that part, this used to be very, used to put project at hold. So you're losing money, you're waiting for a few weeks just to get a part, an insignificant cost part, for example, $5 or $10 that would bring a multi-million-dollar project at a standstill. So when you're talking about digital inventory, and it's being used today in sort of being tested currently by the military. So they're putting these 3D printing facilities either on a construction site or, for example, on military ships out in sea, where you can actually download the file for the item that you want to print, and then you can actually print it on site. This is very effective, for example, remote projects, especially when you're talking like oil refineries or oil and gas type structures, which are in the middle of the desert, and it's hard to actually get parts to, but also to offshore facilities, for example, that are on the shores of the sea, where sometimes you could not fly parts by helicopter, so it's easier to actually have a 3D printer on site and just download and print the item. And again, it's not just metals, it's polymers, it's any other material, but also maybe optimizing an old piece to better get better performance and better structural integrity out of the item that was there before. So Shell is testing this approach for oil and gas and offshore. The military is using that as well. So digital inventory could play a big role, especially when you're in saving costs, time, money, and your discrepancies when it came to when you're demobilizing your projects.
Yeah, but when you explain all, I mean, it seems like you're explaining the concept of digital inventorying, with the, I mean, with the different additive manufacturing processes that we use. So do we have do we have a spare part, for instance, that we can print, that we will need to print in the building industry? It seems a little bit confusing to me. I don't know if
it's not necessarily just the buildings. Again, when you talk about 3D printing in construction, it's more than just walls and buildings and houses. You're talking about spare parts for equipment, legacy equipment or legacy systems that you might have on site. Us as a general contractor, we had a whole fleet of equipment, so excavators, bulldozers, and so on. Okay. So, and most of our equipment was not up to date, so we had to find spare parts for that. Okay. But also for projects that are that exist, if you're looking for a legacy or if you're looking for a spare part for a system, sometimes it would take months just to acquire that part. If you can actually download and print that part on site, you will save a lot of time in terms of cost, delivery time, and the project delays. So when we're talking about 3D printing, we're not talking about necessarily 3D printing a spare wall or a spare fixture or a house. But when you're talking about futures of 3D printing, if you need to print, nothing is saying that you cannot print door frames or windows using wood, plastics, polymers, metals, even fixtures. When you're looking at the possibility of 3D printing, we're not there yet, but there's a lot of opportunities where, like companies like Alchemist, for example, has a vision of having a 3D printer in a house. If you need a faucet knob, you can actually have that 3D printed in your house just by downloading the file and printing it.
Okay. Ina, is it a concept you're familiar with?
Oh, can you say again, please?
Yes. Is it a concept you're familiar with in your project?
So I think it's a bit intersected, I think, of what the Mansour is talking about, probably. Because yes, we can manufacture and additively manufacture parts for the bulldozers and other vehicles, but it's like a kind of like a common way of prototyping any parts.
Okay.
So if you talk more about the actual construction, I think that it's more about not just the walls, but also the formworks. There are a lot of projects right now that I saw when the beautiful elements as a formwork was 3D printed, then delivered to the construction site and reinforced. And that was used as structural columns, right? So in this case, it's not just the walls and the shell of a house, just boring shell of a house. It's actual more elements of the house, but that was produced using the concrete 3D printing. Okay. So I think it's more relevant to the construction. What other part of the house can be 3D printed?
Okay.
Walls, elements, architectural parts, even like a non-bearing, non-structural interior design parts. You know, when you can have a very interesting parametric wall. So I think that also increased the value of the 3D printed houses, and it actually represents the more interesting look on how the houses can look like. And when you use the additive manufacturing to create complex shapes, it's basically the same cost as you do the straight and simple elements. But if you do the same with the traditional construction methods and materials, it can be way more expensive or even not possible at all. That the construction 3D printing and concrete 3D printing unlocks these opportunities as well.
Okay. So let's talk about materials a little bit. Concrete, I mean, remains the most widely used materials in the building industries. But organizations, are still trying to explore the customizable materials. What are the challenges that may arise in developing fully customizable 3D printable materials for construction? Anna?
So we right now use the 3D print material that based on cement.
Okay.
The reason is because the cement is the or like a cement based concrete is the well studied, well recognized in the construction industry, and it's actually a very durable material, and that's much easier to present the emergent technology if you use the well-known 3D print material. If you come to the very conservative construction industry and saying like we have robots, we have this method, and we have this brand new material that never tested before, never used in the construction, but we believe that it's really good, eco-friendly, and we have all of the tests that make the process to present the disruptive technology much harder. But if you're saying that yes, we have the different methods how we fabricate the walls, but the material is still the same that has been used in construction for years. In this case, the penetration to the market, the bar, to penetrate the market it's a little bit lower, right? It's easier to come. But we know that the construction 3D printing and the process of extrusion the material for the construction purposes unlocks the opportunities to use the different materials. It's based on the other materials, not only cement. And so our long-term plan is to transition to cement-free materials like geopolymer. Geopolymer, it's not plastic. Sometimes people think that, oh, polymer, it's plastic. No, it's not. So
Okay.
geopolymer material, it's basically concrete, but it's not based on cement. It's using the other byproducts of the other industries. So it's actually stronger than the concrete. It can be stronger, but it doesn't contain cement or contain very little of cement. So we have the plan to transition to cement-free and more eco-friendly materials, but it's
Okay.
going to be a little bit later.
Okay. Stefan, do you have any challenges, any other challenges to mention regarding, the production, the development of customized 3D printable materials?
Yeah, the key item with the material when it comes to 3D printing is to actually source it or to have it sourced locally. So the key issue is to find what is available locally in terms of materials and aggregates, and try to accommodate that availability when you're 3D printing. It will make no sense if you're trying to bring a material from abroad and trying to develop it in-house when you have an abundance of existing materials that are more conducive to the existing environment and climate and so on. So yes, concrete is a well-known product that's being used today. It's something that is been used for many years, and that's where the industry is moving forward. But it doesn't necessarily mean that that is the only material that can be used in the future. So there are investigations that are happening, like Anna mentioned, in geopolymers and such. And the key item when you're 3D printing is to make sure that you're sourcing local material. If cement is in abundance locally, then that's fine. But if geopolymer is available in abundance locally, then that will be the route to take.
Okay. And do you think, okay, let's pause for a minute because I think that there is one question in the Q&A chat that can be, that can be a complementary question to what I wanted to ask. Now, this one is from Shell Bieber. How do you validate the process? How do you validate the material? Anna or Stefan, do you want to go ahead?
Yeah, there's a whole slew of testing that needs to get done. One thing that we've done with ISO ASTM 52929, which is the standard that we're putting together, is to incorporate or sort of explain how you would actually validate a geopolymer structure. So based on the expertise that we have from the material experts that were on the committee, we're saying that, okay, you can use existing standards to actually validate a geopolymer structure. So if you're doing load bearing or tensile strength or fireproofing, these are, if you're equating sort of the minimum concrete ASTM testing standards for that structure, the geopolymer will probably exceed that, but that will be the minimum requirements that you would need to meet. So with this standard that we're putting out, we're trying to align. Here's a 3D printed element, and here's your construction way of traditional way of actually certifying structures, and this is how you would start off. With future initiatives within ASTM, we're actually moving away from the traditional and focusing primarily on 3D printed elements and the material that's being used for that, and how to actually validate that material and structures.
Okay. Any other insights, Anna, or shall we move to the next question?
Yeah, but Mansour basically described it pretty well. So sometimes people think that 3D print material is something completely new, completely different. It has to be all of the different processes to validate it. But no, it's pretty existing science and industry, I would say, of the materials for the construction. It's dry mix mortars, it's plastering, it's flooring, it's the 3D print material is basically already existing type of material. And for this type of materials, there are a variety of ACTM standards, how you actually need to test the material, setting time, flow test, then the durability test, compressive strength test. And it's something that you need to follow the ACTM standards, and you do the same tests. And this is how you can validate your material and make sure that you produce the material all the time according to standards, and you know that your material is consistent all the time. It's basically quality control process. Before you produce a huge amount of material to 3D print a house, you have to do the quality control of the small batch, for example, just to make sure that the material has the same physical properties. And again, this is something that has been existed for a long time, and we don't try to reinvent the wheel. We're actually trying to follow the existing building codes and try to find a way how we can meet them instead of really change everything.
Okay, so we what you've just said, I believe that this quality control process will vary from one region to another, right? In order for the material to withstand, for instance, the climate in a specific region. Am I wrong?
Yes, no, you're actually right. So the raw materials that use for the 3D print material or any other dry mix mortar, it's basically sand and cement, for example. And these raw materials, they can be different from one mining location to another mining location within 50 miles away from each other, right? You think oh, it's basically the same geographical location, but the mining location is different, and the physical properties of the sand mined between 50 miles from each other from these locations can be completely different. And you need to test your mixture, your 3D print material, if your raw materials are changed, even if you took the sand from the 100 miles away, or even from another mining location. And again, it's something that has been done by the batching plants and manufacturers of the dry mix mortars, and it's pretty standard process. But yes, you basically test it every time to make sure that you don't need to tweak your formula, for example, or something like that.
Okay. And then we'll continue with a comment from Charles. So the issue I see is that the process can fail even if the material is validated. Let's say that ASTM standard is calling for next layer coating, should take no more than X minutes. If a delay of more than X minutes took place, then the process will not meet the STM standard. can you make sure that the contractor did meet the time limit between the layers? Maybe I will let Anna think about it and then give the floor to Stefan to think, because maybe.
Yeah, one of the things that there's with 3D printing now, especially when you're actually printing and the material, there is a constant monitoring of how the material is coming out and being extruded. This is something that is being done on a regular and full-time basis when you're printing. We don't have an automated solution or automated means of actually monitoring the material coming out. So if the weather changes and if it rains or there's sun or there's clouds or the temperature changes, fluctuation, you always have to make sure that your material is consistent with the environment that you're printing in. So when you're talking about testing and you're testing on a laboratory type environment, there's a certain standards that you, or certain thresholds that you would meet, but then you have to actually monitor your material as it's being extruded during your construction to ensure that consistency of the layer is maintained when you're printing. And also the way your topology and the way you're printing your house, you're ensuring the timing that you have enough time to set that material before you come back and then you print over that layer. So there's a lot of monitoring, there's a lot of detail being done in trying to ensure that you are printing the second layer over as a layer that is ready to accept that second layer. So you're not just printing hazmat or just printing randomly. There's a whole structure in the way that you're actually printing, and to ensure that by the time that the print head comes back into your existing location, that you are printing on a very viable layer. So there's a lot of monitoring going on. There's a lot of effort being put into this. This is not something that we just assume just because it passed the certified sort of lab situation, that we can actually say, okay, let's just press the button and everything just goes automatically. There's a lot of interactions during the print in itself.
So we actually have a different point of view. So, and I think that's great, right? That we all have that different point of view and
Totally fine. Don't worry. I like it actually when people have different points of view. So please go ahead with yours.
So, based on our experience, and we did a lot of projects, right? The building in Dubai, for example, we extruded thousands of tons of materials. So although it looks like one building, it actually, the material equal to building the about 13 or 15 single family houses in the United States. So it was a lot of material that we extruded, and a lot of experience and painful processes that we saw, right? So basically what we learned is that if you want to really maintain the consistency of the 3D printed layers, it's not just the printer and it's not just the material. It's also the mixer and pump unit, because this is where the material get mixed, right? And this is where you have to make sure that you maintain the consistent mixing, pumping, and quality of the mix, right? So if you can kind of control this unit, and also your material is produced very, very well, and you maintain the quality of material, and you know all of the physical properties of your material, like initial setting time and final setting time, that will help you to understand what would be the minimum window of time that the next layer has to be layered upon the previous one. So, for example, you have the initial setting time of 15 minutes, for example. That means that only after 15 minutes, you should extrude the next layer. And since we talk about the large scale project objects like the house, typically when you print the one layer of one portion of the house, it's more than 15 minutes, right? So this is why you make sure that the next layer should be fine, and the previous layer also will be fine and will maintain the weight of the next layer, right? This is why we're saying that there is a limitations of how small the object should be. If you want to print something like I don't know, 1 feet tall, 1 feet long, you probably need to do the pauses until you do the next layer. So there are some really basic limitations, but basically, if you have the very good material, you know the physical properties, you tested it, and you know how it mixed, and your equipment is able to maintain the quality, basically, this is how you can guarantee the repeatable builds. and the quality of the actual 3D printed walls.
Okay. Shall I hope these those meet your concern? If not, please share any remarks or any further questions. Let's move to another question. This one is from Steve. That was one of the very first questions we received when we started the conversation. Are there any other geographical requirements to meet in order to build a 3D printed house in a given region? So I've understood that materials, are one of the first items that we'll consider. That will take into considerations into different requirements to build in a given region. But are there any other ones that we should consider?
Just like any other building that you build in different regions, you have sort of like international requirements that are applicable, and then you have local requirements that are applicable. So like printing in Florida, for example, like Anna, there are certain requirements when it comes to hurricanes and certain thresholds that you have to meet. But also, for example, if you're printing in the Caribbean and there's a lot of hurricanes and tornadoes and so on that are happening, for example, in the Midwest, there are certain local and seismic requirements in certain regions as well that you have to meet in addition to that. So you have to make sure that the structure that you're 3D printing does, again, follow the traditional requirements, be it local and international, to actually meet the safety requirements for the whatever region and location that you're in. It doesn't necessarily mean that if you print that you are exempt from your other requirements for local buildings. So you still have to meet stringent, very intense requirements depending on where you're printing.
That makes sense to me. Anna, do you want to share something else?
Yeah, that absolutely makes sense. And it also, I think, more about the structural integrity, right? Because of course, if you build in Florida or you build in California, there are much different requirements to your reinforcement, how you attach the roofing, how you actually reinforce the walls. Do you need to reinforce? Do you need to install the vertical reinforcement every 8 feet or every 12 feet? Right. This is really like what inside the walls and what makes them hurricane resistant or earthquake resistant. But it also, I think that the requirements for the material as well, because like the requirements to 3D print the house, for example, somewhere in Missouri, right, when it's very hot, or in I don't know, somewhere in tundra, that's different, right? And the material absolutely has to be different.
Yeah, sure.
Yeah, I think that's also kind of like a fall to the criteria of geographical requirements.
Yes. And we are about to continue with that with the next question, because Charles opened the debate, on standards. And I would like us to focus a little bit on standards right now. And do we have predefined rules that can be applied in the industry across all countries, or do we have specific rules for each country? I know each of you has something to say about it, given the recent activities of Apiscorp in the field, and then Stefan's, consultancy activities. I will start with Stefan.
So what let me just go back. So the reason I started with ISO and ASTM is because the issues or the standards that are issued by ISO ASTM are globally applicable. So us as a general contractor, when we were working in Dubai and in the Gulf region, but also like as far as Australia, we were still following ISO ASTM standards on the projects that we were doing. So they're internationally recognized. They are existing out there, and everybody's familiar with them. So when we're publishing standards on that level, they are applicable. The standards are translated into 8 languages and used globally. So that's why we're doing it from that standpoint. There are local standards that also need to be applied as well. So in addition to the international standards that are published, there are local standards, for example, in Florida that need to be followed, and there's local standards that need to be followed in different regions based on their requirements. So those are pretty much the ones that we're publishing on a global level are still applicable, but that doesn't mean that they are the only ones. You still have to abide by your local standards, whether they reference the international standards or not. So, but in order to make it comprehensive, we're doing it on a ASTM and ISO standard globally, and which also fell into the EN proposal that came out in earlier this summer, where they are actually putting mandates for 3D printed elements. So every 3D printed element that's coming out in Europe has to abide by ISO or EN certified standard. So ISO falls into that EN requirement so that they can follow that standard when it comes to 3D printed elements in Europe. So yes, there are global, but also there are regional requirements, and usually the regional requirements are more strict than the global ones. So there's a two-layer approach to this.
Okay, fine. Anna?
Yeah, so thank you very much, Mansoor. Very good point. But basically, the standards are really different in country from country, even if they basically follow the international building codes. We all know that cultures are different, right?
Yeah.
Everything is different from country to country. And so our experience so far and how we approach this, and we achieved pretty significant and impressive results so far in that. So, in, so our approach is, instead of try to change the building codes or implement new policies or like standards. Of course, it's something that we understand it will be needed in the future when we scaled up, right, to create more uh, uh, standards for 3D printed houses. But as of today, how we do this, and again, like all of the houses that we 3D printed were built in compliance with the building codes, and they were fully permitted in the United States and in Dubai. So instead of changing the building codes, we were trying to find the way how we can meet them, or how we can build the walls, I mean, 3D print the walls that can meet the existing building codes.
Okay.
This is why we designed the wall structure that structurally is the same as concrete masonry unit block wall. Concrete masonry unit, it's basically this gray blocks, right?
Okay.
Kind of like big bricks. They very well recognized in the world, especially in the United States and in the southern states of America. So we just look at them, and then okay, 3D printing technology provides the so much flexibility what you can 3D print, the shape, the size, and everything. Can we 3D print the shape, the infill of the wall that can be very, very close to the CMU concrete block wall? And we successfully achieved that. So basically, right now, we 3D print the walls that structurally mimic the concrete block wall, something that have been existing for hundreds of years, very well recognized and very well documented. We also reinforced these walls the same way as we would do this for the concrete block wall. So that helped us to talk to the building officials in their language, and basically saying this is just the different way how we fabricate the walls, but structurally they are the same. That's something have been already used in the industry. We can reinforce them the same way. We can install mechanical, electrical, plumbing the same way. We can install the roof in the same way. Everything the same as in the traditional construction. And that's something that helped us to build the homes that permitted and built with according with the building codes. And we recently got the state level approval in Montana for this specific wall that we invented. So that basically meaning that a Montana state, they are okay with this type of 3D printed walls, and they showed the leadership, basically saying, yeah, this is looked at that. And if the cities or counties in Montana state would like to approve that, they they're gonna feel more safe, right? Because they know that the state is okay with that. Because in the United States, you don't need to have the state approval. You have basically, as Mansoor said, it's more local. It's like a county, cities. But even though knowing that state is okay with that, that's a huge step forward. And in Dubai, for example, we 3D printed the wall structures a little bit differently. That was basically compared to the reinforced concrete approach when we 3D printed the formwork of the structural columns, and also we 3D printed the self-bearing walls between those columns. So it's not like a concrete block wall; it's more like a more heavy industrial type of the
Yeah.
construction materials. But again, we also mimicked the concrete reinforced construction, something that also exists in the industry. And this is how that building also met the local building codes.
Okay. So the US left aside different or included, depending on your view on the questions. What will be the next step, to focus on when we look at standards?
There's sort of like a transition when you're talking about standards, like Anne has mentioned, and like we're doing in ISO 529, is first you have to make the construction industry aware of what 3D printing is and how you can actually match it to existing standards. That's the first step. And the way I
Yeah.
try to explain it is like you're trying to change the mentality of horse and carriage to electric cars. So you're not going to jump from a horse and carriage and go directly to electric cars. First, you will take the horse away and then leave the carriage, and then have people just wrap their heads around that concept, and then little by little make that transition to electric cars. And this is what we're doing now. So people have to understand the technology. First, they have to understand what 3D printing is, accept it. Because
Okay.
once acceptance comes into play, more people will use it. More people using it means that there's more development and more research and enhancement in materials and technology and approach. Mass adoption also leads to more usability, so cost will go down because you have a competitive market going on. So there's a lot of issues and a lot of things that are happening for that. But you have to take it one step at a time. And the first step is recognizing what 3D printing is just a different way of building. It's not something that's coming out of the moon. It's something that is very easily usable. And our approach and our goal is just to make sure that 3D printing is another tool in construction. So people will pass by a construction site, see a 3D printer, and not even think twice about it. So
Okay.
there's a whole learning curve that is happening now, and that's the main goal now is awareness, acceptance, and recognizing what the technology is. Once they accept it, then we start moving away from the traditional means like rebars and traditional lost formwork filling with concrete, and then maybe designing our walls in a different way that we offer better structural integrity, better thermal performance, and not necessarily having to resort to your traditional beams and column type structures, and having walls that are just load bearing without any additional support.
Okay. So let's talk about cost. So many of the headlines that we read today, that we see today, talk about social housing projects. How does it work? And I believe that, yeah, it can, bring some sort of confusion, in the mind of people who, are looking to, to build 3D printed house themselves. So, Anna, I would just ask you the question first, because I know Apiscars is currently involved in a sort of affordable social housing program. So I would really like to hear your point of view on this topic. How does it work?
Yeah, so that's pretty sophisticated, I would say, subject of this technology,
Yeah.
because people think that the 3D printed houses are cheap, right? That's not the truth. And even the 3D printing technology is not the answer for affordable housing. However, it's the very important piece how we can achieve that. So I had the entire TEDx talk about that when I'm saying that 3D printing technology is not the universal solution for that. So I just want to be really clear that when we talk about 3D printed houses, it's not necessarily just cheap, affordable, and cure for all of the wrongs that we did in the construction before, right? So because
Yes.
you also need to know what the robots you use, right? I'm very open about that, that I do not believe in the genre printers because I know the cost associated with the transportation, deployment, and operation of the huge, bulky gantry printers, which are very popular today. So I just know that the price may be as big as like a $10,000 or $15,000 just to set up this huge machine. And I'm talking about the US market. So
Okay.
$15,000, you actually can build something, not just to install the printer, right? So
Yes.
this is a lot of hidden costs that not only about the material or the way you print, but also what type of equipment and technology you use, right? So when we talk about our technology, because like it's something that we can speak about confidently because we understand our costs and projections for that. So our projections is that we can 3D print homes, finished homes in the United States up to 30% less, and it's up to. It's not just by default 30%. It can
Okay.
be even like a 5% less, right? Because finished house consists of a lot of different pieces. It's the walls, it's finishes, it's furniture, it's like the roof system, right? It's something that 3D printing technology cannot really reduce the cost for the roofing, for example. However, with the 3D printing technology, you can apply a lot of value engineering. For example, you can install the insulation inside the wall. This is how you can get rid of the drywall. And drywall, it's like a more labor, more materials, more everything. So this is how
Okay.
you can reduce the cost for the drywall, for example. Then how you install the mechanical, electrical, plumbing. It's also a lot of ways how you can do it better and cheaper and faster if you apply if you do this for the 3D printed walls, right? So it's complex, and if you apply the very good value engineering, you really can achieve the price. In case for our technology, up to 30%. This is our projection today, and but it's also for the United States, or maybe for the Canada as well, because
Okay.
every market is different, right? Labor cost is different. So this it's really, really, really important to say that this is the potential price to 3D print the finished house in this particular country. Because like if you compare United States and I don't know, for example, uh, a country in Latin America, it's going to be completely different. The labor cost there is different. Materials there cost also different. So, my universal answer is that for our technology in the United States, we can achieve the cost of the finished house up to 30% less. But you also need to understand that it's probably going to be pretty simple house look inside, just painted walls with the conduit. It's not going to be the golden toilet inside, and all of the very expensive finishes. So
Yeah.
it's going to be a pretty simple house.
Okay. So Anna, if we had to put some figures, because I know I mean you've talked about it in terms of percentage. Yes. And why trying to respond to Eliseo, who say, what does the price range of 3D printed house look like when compared to a house that is conventionally made? If you had to put some figures just to enable the audience, to figure out, the kind of market they are dealing with. I mean, those who are not contractors or, those who are neither contractors, no manufacturers, or, not related to the building industry at all.
So this is very, very dangerous question for me
Yep.
to put some numbers or something.
Let me try to interfere here.
Thank you.
Anna, thank you so much because the information is amazing. There's so much associated. I mean, when you're looking at a construction cost, I mean, as a general contractor, I would not go to a general contractor and say, okay, how much will it cost me to build a
And that's
five-story?
right. That's right.
So as a general contractor, you would not ask that question because there's so many factors. I mean, where am I getting my equipment from? Where's my labor from? Where's my material coming from? What type of material do you want me to build? So there's a lot associated with that. One thing you have to keep in mind that when you're comparing costs between 3D printed element and traditional housing, there is so much that you need to take into consideration. Am I building one house? Do I need to bring the printer from the other side of the world in order to actually print that house?
Yes.
What material do I need to use? Do I need to test the material? Am I testing the material locally, or am I testing it in the Netherlands and bring it back here? And then I have to do more testing because it's locally now. So there's so much that goes on with 3D printing of a house. And trying to equate 3D printed houses with traditional, not at scale. So like I cannot compare one house where I'm mobilizing everything to that single 80 square meter house to when I'm comparing to traditional housing that everything is sourced locally.
Yeah, you're right.
There's so much that goes into that when you're talking about cost, and also what Also, what you have to keep in mind that when you do 3D printing, your go-to-market is quicker. So I'm not having so much equipment on site. I'm delivering my house faster, more efficiently. Maybe the labor that I'm using is not necessarily has to be on site and they can move on to the next project. But there's also the running cost of the 3D printed house. It offers better insulation. It offers, if there's flooding or seismic activity and my house is still standing after a fire, I don't have to worry about that. I have to rebuild my house every 5 years because something happened to it. So there's so much that goes into that, and those intangible costs that are there that you cannot put a dollar value to as of yet. So there's so much that needs to be done yet. And until we do things en masse, like 50, 100 plus houses, and we refine the process and we refine the material and refine the suppliers, that's the only way we can actually then say, okay, this is how much it will cost to 3D print and this is how much it costs to traditional. But until then, that question is like that's plaguing our industry. It's impossible to answer. And although we would like to give you the magic answer that yes, it's cheaper and yes, it's faster, we cannot give that number to you. We cannot do that as of yet because nobody's doing that en masse. I cannot come and say you built a neighborhood for like 5 blocks of houses, and then you're going to tell me how much it's going to cost to 3D print. We don't have that scope yet, so we cannot answer that.
Yeah, and I absolutely agree because as of today, we in the process to scale. Yeah. So this is why we provide all of the numbers for the future when we scaled up, right? When we, for example, have hundreds of printers in operation. So we are trying to achieve that goal in 1-2 years, right? So next year for us, it's going to be very important and very busy when we go into to start doing the project on mass scale. It's basically the economy of scale, right? Okay. So in the future, when the technology is scaled and successfully adopted and work on the macroeconomic, this is when we can say like, oh, now we achieved the house, let's say 1,700 square feet house for $110,000. I'm just making up numbers right now, right? But that's something that gonna be possible in the future when all of the companies doing the 3D printing technology and providing equipment gonna be on a more scaled phase. It's basically the same as Tesla. In the beginning, it was very expensive, but as they were growing and scaling up the manufacturing, now the price for Tesla is more affordable, right? So I would say that in the future, 3D printing technology definitely will allow to have the houses much more affordable. I don't like the word cheaper. I'm saying more affordable. So yeah, and it's again really depends on the design, on the floor plan, of the size of the house, all of the finishes you want to apply. And this is actually the affordable housing program that we created in EpiScore, how we approach that. Instead of saying like, oh, let's build a house for $50,000. What house, what design? We don't care. Let's have it just going to be $50,000. We do not do that. Okay. We say like our affordable housing program right now is first phase when we decide what you want to build, what the requirements of your neighborhood, of your society, and their particular city, for example. What's the size of the house? Maybe it's a tiny house of 200 square feet. Maybe this particular neighborhood, they need a house of 1,700 square feet, right? Okay, how are they going to look this house inside? Do they need to have drywall, or are they just going to be okay with the painting? That's really a factor of the prices. So the first phase that we're doing, we're trying to figure out this concept, what's going to be the deliverables, and then we see how the technology can make this happen by applying of the value engineering, material price reduction, or something like that.
Okay, thanks, Anna. I myself won't even ask this question again. So you made it very clear. You made it very clear, Stefan and Anna. Mark, I think that I probably missed the question because you wrote the moon. If you can just be clear about the question you would like to ask Stefan and Anna. Maybe you commented when one of them was speaking and then I didn't catch it at the right time. So it would be great if that's that was a real question about the moon. So before,
yeah, I'm really intrigued about this question.
Yeah, right. Because you just wrote the moon, and I was like, okay, maybe he wrote that when one of you was speaking, and then I didn't catch, I didn't catch it. Yes, at first glance, yes, to say it out loud. Anyway, we are almost reaching the end of the panel. I don't know if Stefan or Anna, do you have any questions for one another before we go to the closing notes?
No, I look forward to the advances that are happening with Apiscore. I look forward to following them. I'm eager to see their projects and their successes moving forward. So, but as far as questions, no, we're
No.
okay.
Yeah, thank you. And we actually talked to Mansoor, I think like 2-3 years ago when
Yeah.
you started with your initiative for the standards. So I'm really happy that you progressed so far, and that's really excited and see you again. So yeah, thank you very much for organizing this webinar. It was a lot of fun and
I
pleasure to talk about this.
I
Yeah.
appreciate it. Do you have
Maybe
any?
next time we can talk about costs. So we'll see.
Yeah.
That's it. That's so right. Do you have any last thoughts before we close the panel? Do you have any last thoughts to share for the audience or for the industry, how we should move forward?
I just have one note. When you're looking at 3D printing, don't think that it's some kind of like off the world technology. Just like you would approach any construction project, that's how you approach 3D printing. You are supposed to 3D printing is supposed to address a pain point and a specific pain point, and maybe 3D printing may not solve that pain point, but if it does, then you would move forward. You won't buy. No construction site or no general contractor is going to buy $1 million crane and put it on site and then scratch their head and figure out what am I going to do with it. So you have to have a realistic approach to why you're using 3D printing, what you're trying to address for it, and just like any other project in construction site, it has its process. So it has its mobilization, it has its cost analysis, it has its resources, and there's planning. So it's you would approach any a project just like any other in construction, but also it doesn't mean that you have to buy a printer. You can there are solutions out there where you can hire as a subcontractor. So don't feel intimidated that you're stuck with a big investment upfront in order to actually achieve 3D printing projects.
Yeah, and I would actually add to the subject about the price for the house. I would add that it actually the problem today not just how to build it's more affordably. If you look at the national home builders in the United States, they actually have a very good internal price to build the house. They just sell it for pretty high price because they can, because there is no enough inventory in the market. And it's just the basic macroeconomy science. If you don't have a lot of supply but you have a huge demand, the price for the houses for the product of course is going to be high, right? And the 3D printing technology, it's not just how we can build like more affordably, but how we can increase inventory in the market and have more houses built, right? In this case, if we have more supply in the market and more inventory, this is how we can try to meet the demand. And this is where all of the macroeconomic magic start working. And this is why the sellers, they will need to reduce the price for the houses because now it's more supply in the market. So I would say that when you think about the 3D printing technology, it's basically the tool how to automate some of the processes and how to increase productivity, how to build more homes within the same period of time with better quality, so you don't need to redo the houses or all of the errors. So this is really like a really efficient tool how we can try to crack the code of the construction and rethink the construction.
Okay, great. Well, on these good comments, I would like to thank you, Anna and Stephen, for joining us today and for making this conversation a captivating one. Thank you to the audience. Thank you for your questions, for your remarks, for your insights into this specific topic. Please stay tuned for the next panel that will be announced very soon. And I will now close the panel and wish you a very nice day or nice end of day if that's already the evening where you're located. Stay tuned and stay safe wherever you are in the world. Thanks.
Thank you. Thank you, Stefan.
Thank you very much. Nice seeing you. Take care.
Bye.
Bye.